Hi, I'm Clay Naylor, and this is my video project.
I was given problem 9, and for that one our function is f of x equals x cubed minus 3x squared plus 2x all over 2 to the x minus 20. And our first problem that they gave us is we have to find the relative extrema. So first we have to take the derivative of our function, and we have to use a quotient rule for this one. So we use our low d high minus high d low all over low squared formula. So I separated it into low and high and found the derivatives for both of them. And then that brings our derivative to 2 to the x minus 20 times 3x squared minus 6x plus 2 minus x cubed minus 3x squared plus 2x times 2 to the x times the natural log of 2 all over 2 to the x minus 20 squared. Next, we have to set that equal to 0, and then we can just put that into solver, and we're going to get 0.4, 1.62, and 13.1, and those are all of our critical numbers. So then we just take our critical numbers and put them on a number line, and we take our derivative and we put it into our y equals on our calculator, and then go to the table, and then we have to guess numbers a little less than 0.4, and then a little more than 0.4, a little more than 1.62, and a little more than 13.1, and that's going to tell us if it's negative or positive. So then this will help us find our relative mins and max. So at a relative max, we go from positive to negative, and at a relative min, we go from negative to positive. So we're going to have a relative max at x equals 1.62 and a relative min at x equals 0.4 and at x equals 13.1. So for the next step, we have to find our absolute extrema. And we already did the first steps of that, which is finding the derivative, setting it to 0, just putting into solver to find our critical points. So all we have to do is look at our critical numbers and see that only one of them is in the interval that was given to us, -5 to 1. So that means we can get rid of 1.62 and 13.1, and we're just left with 0.4. And then we make an XY chart, and we include our critical number that we found before, and then we just take our lowest number in our interval and our highest number in our interval. Then we plug this into the original function up here. We get our numbers, and then we can see that at -5, it's the highest. 10.56 is greater than those, so that's where our absolute max is going to be. And then at 0.4 is our lowest, so that's where our absolute min is going to be.